And 8 just means that the atomic number equals the number of protons equals the number of electrons. We're going to put that right up there by the given box from the periodic table. Number 2, we're going to point an arrow right at the atomic mass, and we're going to denote that that means protons plus neutrons. So that's the next thing you need to write on your periodic table. Number 3, we're going to talk about mass now, or excuse me, man now. So man is an acronym that means atomic mass minus the atomic number equals the neutrons. So you'll see the M in mass and the A in atomic number and the N in neutron all are an acronym for this little mini formula hack. Okay? And you can even circle it, man. So if you're ever given a problem where you need to find neutrons, you can plug in your information given and go from there. Fourth, we're going to talk about where the valence electrons are on the periodic table and how you can determine how many valence electrons each particular element has. So I'm going to write valence electrons up at the top here, and then I'm going to draw some arrows to each of the groups and families, just a couple of the groups. I'm not going to draw it to each one of them, and I'll circle the group number or the part of the group number that represents the valence electrons. Notice that group 1 and 2 are also 1 valence electron and 2 valence electrons. But then we start working on groups 13 through 18. I'm going to draw a couple arrows over to maybe 13 and 18. And we have to drop the 1 off to make sure that we have the correct number of valence electrons. So for example, this one is group 13, but only 3 valence electrons. And then the next one would be group 14, but only 4 valence electrons. So everything in that group, or in that family, it will have the same number of valence electrons and the same reactivity. All right, now we're going to move up to talking about groups or families a little bit more. So above, about 16, group 16, we're going to write that these are called groups or families, and then I'm going to circle this particular group or family. And what this means is that everything in this group or family has similar properties and similar reactivity. So I'm going to also put a box around 16 to show that that's the group number. I don't want you to confuse the group number with the valence electron number, because this is actually the full number there. So in this particular case, oxygen, sulfur, and so forth, selenium, tellurium, they're all going to be have similar reactivity. All right, moving on, we're going to now go over to the rows, which are called periods on the periodic table. And make sure we have reactivity on there, because that's what that group number tells us in the valence electrons. And so now we're going to move over to the periods, and these are the rows. These are the horizontal rows going across the periodic table, and they tell us a couple of different things. They tell us the number of energy levels, or they tell us the number of energy shells in an actual Bohr model. So I'm always going to label periods across the side here. I'll put in parentheses energy levels and energy shells. You'll be real surprised how many questions will pop up on this STAAR test that will be able to be answered by just having this little brain dump in front of you. Now, we're going to move down to the bottom of the periodic table, and we're going to talk about reactivity real quick. I'm going to draw a big long arrow going from right to left, and I'm going to label it increasing reactivity. So as the arrow moves toward the left, or as the groups move toward the left, they get more reactive. So we're just going to write increasing activity down towards the bottom. The most reactive group or family on the periodic table is group 1. So I'm going to just put a little most reactive down there, just so I know that those are highly reactive. They have 1 valence electron, and they want to give that thing away as fast as possible. They react very violently with a lot of different other elements. Now, going back to the other side, group 18, these are the most stable. So I'm going to write most stable down here. And this group has a special name. It's called the noble gases. So just right underneath the element radon, I'm just going to write noble gases, just in case that happens to pop up on the test. But these guys are real stable. They're not giving any electrons away. Their electron shells are totally full. All right, so the periodic table is totally marked up. Now we want to go back to the top of the periodic table, and we're going to start talking about different other chemistry principles. So I'm going to focus in on this top left corner, and we're going to first talk about a compound known as glucose, which is C6H12O6. We're going to make some comments about it real quick. Seen this before show up on previous STAAR tests. So 3 elements. It has 3 elements, and you do that by counting the capital letters: carbon, hydrogen, and oxygen. So 3 elements out to the side there. And it has a total of 24 atoms. We do that by counting the subscripts. That's the little number behind each of the particular elements. If there is not a number there, then it is implied that it is 1 atom. It cannot have a letter and not have an atom, so it has to be a 1. In this case, it is 24 atoms. All right, the next thing you need to know about chemistry is the RAP acronym that we gave you. And this is talking about balanced and unbalanced equations. On each side of the arrow, there are reactants on the left and products on the right. In order to be balanced, they have to have the same number on each side, the same number of atoms. We call this RAP because there's an R in reactant, the A stands for the arrow, and the P stands for the product. Right? If it's totally balanced, then those numbers will totally match up. Okay, now let's go to the subatomic particles. We're going to be talking about protons, neutrons, and electrons. First, we're going to talk about protons. Protons, and we're going to list the charge, which is positive. They are found inside the nucleus. Zoom this in a little bit more so you can see it. All right. And then next we have a neutron, which is a negative charge, or no charge, or a neutral charge. And they are found inside the atom as well. And then the electron, which is negative and found outside the nucleus. Also want to make note of the top 2, the protons and the neutrons, make up the most mass of the atom. This is where all the mass is found in the atom. Electrons have a tiny, tiny little bit of mass, but not that much. Most of the mass comes from the protons and the neutrons. And now as we move to the top right corner of the sheet, we're going to now talk about metals, metalloids, and nonmetals. So metals, we're calling those on the left side of the periodic table. So basically anything to the left of the staircase on the periodic table, we're saying is a metal, and they have similar properties. They have a shiny luster. That means they're shiny. When you look at them, it's the way the light reflects off them. And then they are malleable, which means they can be pounded into sheets. They are also good conductors, and they are poor insulators. You could also mention that they are ductile as well, which means they can be pulled into a wire, like you'll see in copper wire in all your electricity around your house or your school. All right, next we're going to talk about the metalloids. And metalloids are found usually touching the staircase on the periodic table. So they're touching that black line that looks like a staircase on the periodic table. And all those are metalloids except for one, which is aluminum. And that's just one you have to remember is a metal. When you think of aluminum, it does look like it has lots of properties of metal, so you want to make sure that you know that that is actually a metal, just in case that pops up. All right, so metalloids have properties of both. I'm not going to list all the properties here, you just need to know they have properties of both. They could be shiny and they could be brittle. So, all right, and then lastly, we have nonmetals. Nonmetals are on the right side of the periodic table, not generally, they are to the right of the staircase. And they are mostly gas. There are some exceptions to that, just like in everything in science. And they are dull, meaning they have no shine to them. Kind of think of chalk when you think of dull. Even though chalk is not an element, it has a dull texture. They are good insulators. And they are poor conductors. All right, so this is the periodic table.